You are now tuned in to the network, the YouTube channel that takes complex networking topics and dumbs them down to a more simple language. Today's topic is section 6.6a, Static NAT, Dynamic NAT, and PAT, or Port Address Translation. This is a subsection in the section Configure and Verify IPv4 Network Address Translation, or NAT. This is a topic in the CCNP route exam. It'll be known as the CCNP Enterprise exam come February 2020. Let's go ahead and take a look at the exam blueprint to see where we came from or where we're headed. Hashtag labeveryday. Go ahead and visit labeveryday.com. Also, be sure to hit that like button and please subscribe to my channel, Network Bro. All right, so this is the exam blueprint we've been following, implementing Cisco IP routing, exam code 300-101. It'll be known as exam code 300-401. We just wrapped up the section DHCP options. All we did was describe them. Today, again, we're going to be doing network address translation. We may split this up in a couple videos because I do have one lab, but it's a pretty long lab that covers all three topics. So static NAT, dynamic NAT, along with port address translation. After that, we'll move on to IPv6 NAT. So let's go ahead and start off with static NAT. Well, what is network address translation? Well, we know that when we're talking about IPv4, we have public IP addresses and private IP addresses. Why do we do this? We did this because basically we were running out of IP addresses, right? We have like 4.2 million something addresses. You think it's a lot, but no, it really ran out really quickly because we didn't realize how exponential the internet would grow, how fast it would grow. And we ran out of IP addresses. So by using public and private IP addresses, that was a way to kind of like recycle them in a way. Not necessarily recycle them, but we can have one organization or one place that has a whole bunch of IP addresses internally, but when they get out to the internet, they're going to use just one IP address when they're exiting out of their interface or exiting out of their network. Let's head over to the slides for the official definition. Okay, shout out to simplewikipedia.org. I'm going to start getting my definitions from there. Yes, we can get them from Cisco as well, but y'all know I like to keep things very simple so that way it doesn't intimidate people and let them think they can't do this, right? So again, this was from simple.wikipedia.org. In computer networking, network address translation is a technique of modifying the network address information in the IP packet headers. I guess that's still kind of blah, 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 right? While transferring the packet across a traffic routing device. Such a technique remaps a given address space into another address space. This allows multiple computers to share a single IP address. Remember what I was talking about? We have a whole bunch of people on the inside of our network. When they leave out of our net, when they go out to the internet, they're going to be using just one IP address, even though they individually have their own IP. How do we do this? Because we have public versus private IP, or private versus public, right? Which has become necessary because there are not enough IP addresses for every computer in the world. Not even just every computer, every microwave, every car, every refrigerators that have IP addresses now. You got your laptops that got IP addresses. Your smartphones, almost everything has an IP address. We can't give everybody a unique IP address. So this is how we do it with network address translation, right? You look at this topology right here. We got this computer that has 192.168.100.1. He's 100.4, 100.5, right? If we have more, we have so on and so forth. But notice they all start with 192.168, right? These are considered, this is a private IP address range. The ones that start with 192.168.1, right? So this is the local area network. Their default gateway is 192.168.1.1, but when they leave out of the internet, they are all going to be using this public IP address, 145.12.131.7. So when anybody over here out in the internet wants to reach us, they have to hit this IP address, not that IP address, right? Because this is our private IP address. These people out here are not going to know our private IP address, right? Because we're masking it with this one single public IP address. And this is what this is the basic concept of how network address translation works. However, like I mentioned before at the beginning of this video, there's different ways we can translate networks or network addresses. We have static NAT, dynamic NAT, and also port address translation is another way we can do some natting, right? So here's another refresher on some simple terms on IP addressing or network address translation. You have your inside local address, right? This is, we're going to be reading this from left to right, right? So we're starting over here, inside local. This is you and your PC or your refrigerator, whatever, your microwave that has an IP address, right? This IP address, the inside local, is assigned to hosts on the internal network. There are no advertised There are none advertised outside the network. So you won't see this address on the network outside, right? You'll see it inside. Like, let's say we have a smartphone and we're on the local area network and we need to talk to this guy. We will see this IP address, right? This because this is the private network and he's within that LAN, right? Then we have our inside global. Now we're still inside, right? Because here's the internet right here, right? We're still inside, right? The inside global IP address is the IP address of the internal host as it appears to the external network. So this is almost like that public IP address right there. Even though it says public, it's still on the inside because it's global, but it's internal to us. We know that this is our outside IP address, right? So this is inside global though. So for example, this would be public IP of your internal network, right? So that 12.1.1.1. So this address is going to be that address once it reads outside, right? Then we have the outside global. So this would be like the other router, like when you're going to a destination, basically their edge device, their WAN router, if you want to call it, whatever. This is what the internal network sees as the IP address of an external device, right? So we know if we're trying to reach somebody else's network and they're outside of our network, their public IP is 13.1.1.1. That's their outside global. This is what we see from internal, right? An example of this would be public IP address of an external website, right? This was the public IP address of the internal network, right? So that is the outside global. I need inside, outside global. I know it can be kind of confusing, but I chose this graphic right here. Shout out to whatever website it is. I can't remember, but if you just do a Google image search, you'll see this image right here. This is the simplest way to explain that network address translation, right? So that is the outside global, right? And then outside local would be this would be the internal address, but we're not going to know it from here. We're not going to be able to see it. We're only going to know their outside global address, right? This is us right here, right? So the outside local is the IP address that is actually assigned to the external device. This is the private IP of that address. We're not going to know it because it's private. We're only going to know their outside facing IP address, which is on their outside global address. We're going to know that. This is the private IP address that is usually not known to your local network. So again, we're not going to know their private IP address. We're only going to know their outside global address. So take a look at this slide right here. That really helps with network address types. How do we define what's inside, what's outside, etc.? This is real simple. If you just kind of like ignore the descriptions, which makes it more intimidating. Ones that say like description LAN interface, description WAN interface, right? We know to get in the interface config mode, we do interface FA and then whatever interface it is, FA10, right? We're gonna declare this as the inside interface by doing IP NAT inside, right? So if we go back to this slide right here, this would be our NAT inside interface. Y'all get that? From us, that's our inside NAT, right? And then we would do our outside interface serial 10, IP NAT outside. So from the outside, this is the outside interface. It's facing the public facing side of the internet, or of our router, our edge router. So that's the first thing we do. And then when we're talking about static NAT, which we're going to cover now, and I think we're going to separate this in 3 separate parts, because y'all know I like to do this in like meat chunks, so to say. Shout out to LAN Tamer. Y'all check him out in his Discord. LAN, that's LANTAMER, right? So static NAT provides one-to-one mappings from an inside local address to an inside global address. In this case, you will always have the internal address using the same global IP address. So how do we do that? It's a pretty lengthy statement, but it's at the same time, it makes kind of sense, right? All of our NATing starts with IP NAT, right? So in this case, it was IP NAT inside, right? IP NAT outside, right? When we're doing a static NAT, we're doing IP NAT inside source static. We're saying static, and then we put the local inside IP address to the global inside IP address, right? This is one way to do it, right? So an example of that would be IP NAT inside source static, and we're going to map the outside address 55.555 to the internal 192.168.1.5. So this is a static one-to-one mapping. Now, this is not very scalable because we're pretty much using one single IP address to one public facing interface. One inside to one public facing. That's 1-to-1. We can quickly run out of IP addresses here. But this is one way to do network address translation. And we're going to fire up Boson NetSim and play with that. As a matter of fact, let's go ahead and do that. This is the Route Lab Network Address Translation, Section 1. So this is an actual Route Lab that is used in Boson NetSim. Y'all know what it is when y'all see this little girl. So let's go ahead and play with Static NAT. All right, so here's the lab we're going to be working with today, Network Address Translation 1. This is the topology. Let me widen this up so y'all can see. So we got pod 1 on the left-hand side, pod 2 on the right-hand side, right? So again, pod 1 right here, pod 2 right here. We're going to be, and then we have pretty much the backbone or the internet right here. We're going to be making this inside zone, that an inside zone, and obviously this is the internet, so this will be considered outside. And also, depending when you look at it, if this is our inside over here, then this will be considered outside, and that's outside, and then vice versa for this side, right? So this is some basic commands right here. We can clear our translations with that command. Obviously, we know how to do an access control list. If you don't, go a couple videos back. Here's our commands for setting up NAT. We got a couple show commands here. The main one we want to look at is probably show IP NAT translations right there. This is the IP addressing guide. We can skip this and let's go ahead and prepare for NAT. First thing says here, when static NAT is configured, the route will translate the private inside local addresses to an inside global for advertisement, right? So private inside local to inside global, right? So from that address to that address, basically. In order for the devices on the network to send packets to the 172.16.0 network, an interface must be configured for the address to be advertised. So on P1R1, when we go to P1R1, which we are on them, change the loopback IP address, the loopback 0 IP address to 172.16.1.1, right? But let's see what he's got so far. He says to change the IP. Show IP interface brief on P1R1, and we'll see that we don't even have a loopback. So I don't know why they said that. That's what I'm confused about with this lab right here. But we're going to go with that anyway and just create one. So we're going to go to global config mode and say interface loopback. Let me write it out completely. 0. And we're going to give them the IP address of 172.16.1.1. And IP addresses, or the subnet mask 255.255.255.0. Right? I'm going to say a no shut because it didn't look like it went up automatically. But then again, this is a simulator. Remember? This simulates how iOS works. And on the same router, we're going to step 2 says to configure RIP version 2 to route for the new network. What was the network? 172.16.1.0 network, right? So we are going to go to global config mode again and say router RIP. He said we want it in version 2. And we're going to advertise network 172.16. Pretty much 0.1.0 really 1.0, and then the network was I don't know if we can do subnet mask with RIP. Can we? No, I don't think so. But if we do that, it should automatically, this is class full, right? RIP is a class full routing protocol. So if we do a show run, you'll see that turned into 172.16.0.0, right? Even though we put no auto summary. So like I said, y'all know how I feel about RIP. So anyway, on P1R1, which is this guy right here, he wants us to ping P2R2 or P2R1's loopback 0 interface, this guy right here. So he wants this guy to ping that guy right here to verify connectivity. The ping should work. So we're going to ping 172.16.2.1. We do that and we got a success. Perfect. That's good. All right, so inside local to an inside global. So we're going to map this one particular address to that. That's called one-to-one static NAT, a one-to-one mapping. Again, that's not very scalable, but that's what they want us to do. What I mean by not scalable, meaning we can quickly run out of these, mappings here because we're pretty much, that defeats the purpose of NAT in a way. So we're going to go to global config mode. Well, don't defeat the purpose of NAT, but it defeats the purpose of trying to reserve our IP addressing scheme. Configure serial 00. So we're going to go to interface serial 0/0 as an inside NAT interface. Inside NAT. How do we do that? We say IP inside or NAT inside. So we go to interface config mode and do IP NAT inside. Same thing with the outside. We just put the outside keyword. If we want, we can put some descriptions, but that's not necessary for this lab. So we're going to say IP NAT inside. So the serial interface, this guy right here, is going to be our inside IP address, right? Or inside interface rather. So that's inside. Step 2, configure P1R1's FA00 interface as an outside NAT interface. So so this is our inside interface, that is our outside interface. So my bad, not the actual host, but the interface is on the router. So that's inside and that's outside. Hope that makes sense. So now we're gonna go to interface FA00. I hope y'all hear that. That's a hurricane coming right there. It's slowly creeping up to us. Hurricane Dorian. Again, I'm in Central Florida area, and I'm starting to hear the rain now. Anyways, interface FA0/0. We're gonna give it the IP NAT outside. So that's our outside interface, right? Configure P1R1 to statically translate 1031.6, which is P1R2's 000 interface. We're going to statically translate that to P1R2's 000 interface. We're going to configure that router to statically translate that IP address, this one right here, to P1R2's 172.16.1.100. This IP address right here. So we're just going to say, how do we do that? We said, for static NAT, we put this long ass statement here. IP NAT inside source static. Then we put the inside local IP versus, and then the inside global IP, right? IP NAT inside, right? And the next keyword was source static, right? And then we put the inside IP address, which would be this guy right here, 1031.6, which is that right there that I circled. 10.30.1.6, and then we put the inside global IP, which will be this inside global, which will be the next router's global IP address. So 172.16.1.100. What IP address is that? That is 172.16.1.100. It's not even the IP addressing guide, so it's probably, I don't know, but that's what they wanted us to do. That's probably, it could be a host that's on here if we wanted, whatever. But let's go ahead and do it. So we went ahead and did that, right? From P1R2, so this guy right here, ping P2R1's FA00 interface 100.100 or 10.100.102. So we want P1R2 to ping that interface right there, this guy right here. And that's what we want to do. Ping 10.100.100.2. The ping should be successful. It is. Good. From P1R2, telnet to P2R1's FA00 interface. So now we're going to do the same thing here, but now we're going to telnet to it, right? Let's go ahead and telnet to 10.100.100.2. What's password? He said the password is Cisco. And now we're telnetted into it. From the telnet session to P1 or P2R1, display the users that are currently logged on. The source IP address of the VTY session should be the statically translated IP address. So we're going to go to here and do, I believe, a show line. No, show line. It's not show line. We want to show that, so we want to display the users. Show line users. What is that command? Show the users. Yeah, show users. Okay, and then display the users that are currently logged on. We got a star here. That should be us. That's the active session. The source IP address of the VTY session should be the statically translated IP address. What that address? 172.16.1.100. So basically, we put an IP address 172.16.1.100, which I believe. Let's see part P2R1. Let's look at his interfaces. We're going to look at his interfaces. Show IP interface brief. we just mapped it to looks like just an outside. We just mapped it to I guess an arbitrary address and telnetted into that. So it says here disconnect the telnet session. So we're going to disconnect this session that we got over here. All right, so we're going to go ahead and disconnect that by just doing exit. All right, now we're back onto this router here. Right, on P1R1. So we're going to go to P1R1. We're going to go to this guy right here now. Display the NAT translation table. If you do not see a translation, it might have timed out. If this is the case, refresh the IP NAT translation by pinging the router P1R2 to P2R1 faster than Ethernet 00 interface, then display the NAT translation. How do we say we do NAT translation? We view them? Well, I guess I never really mentioned that, but it's show IP NAT translations. I did mention it up there, I didn't know. So here is the mapping here. We mapped 172.16.1.100, which I guess we said that was going to be his global IP address, this guy's global IP address, to the inside local 1031.6, which is his serial number. So we mapped this serial interface to this guy right here and said that's going to be 172.16.1.100. In the next video, we're going to cover dynamic NAT. Remember, I said I want to do this in little meat chunks. That way, y'all don't digest this stuff like it's like trying to drink from a fire hydrant. So we're going to go ahead and cover dynamic NAT in the next video. That's all I got for y'all today. We're going to again cover dynamic NAT in the next video. Like I said, I want to do this in small little nuggets. Y'all know how I do with these videos here. That is my YouTube page. That's my Twitter handle. Go ahead and add me on Twitter. Send me a message. Leave a comment below if you like these videos. Please share this video with anybody trying to get into computer networking. From now, please comment, like, subscribe to the network.